All right, here we go. This is going to be a quick review of the test because we need to double check. Some people were really good. Some people scored really well. Some people didn't. Hopefully you've already reviewed your scores. The scores are accurate, unfortunately, for some of you guys. We need to take a look at, I'm going to go question by question. So this might be a longer video, but I think it's kind of important that we look at the ways we can improve and problems that we had on this specific quiz, because this quiz should have been fairly simple because it was very similar to your homework. Um, that being said, let's take a look real quick. Number one is basically the marathon question. They give you, in some cases, 2.5 hours. Another version, with one version, it was 37 minutes, and in some cases 10 seconds. Everyone got a different version, so we're going to do a generic version. Well, hours, minutes, and seconds, almost everybody across the board said, hey, that's good. I understand. Give us a second to focus. Everyone understood, hey, I got to get those into seconds. So 60 minutes and 60 seconds, 2.5 hours times 60 minutes times 60 seconds. That's 9,000 seconds times 60. 37 times 60. 2,220, and then 10 seconds is 10 seconds, so plus 10 plus 9,000. 11,230 seconds. Well, then they gave you a velocity of, in this case, I think it was 5.733 on this version, meters per second. Well, depending on how you want to solve this, you can go to an equation, you can go dimensional analysis wise. If you just say, I have 11,230 seconds, good gravy, and I use this 5.733 meters in 1 second, you should get the answer. Significant digits weren't counted on this question, so depending on how you did the math, you should come up with a big number, and answer was in meters. Honestly, a lot of people got that question correct, so I'm not going to spend a lot more time on it. Number two, this is the flagpole one. Flagpole, so basically you had to draw a diagram. In this case, we had 17 kilometers on this side, and in this version, 16 kilometers on this side for our runners. This one was going at 11 kilometers an hour, and this one was going at 10 kilometers an hour. A lot of variations on this problem, but that's the gist of every single problem. You had two distances, two speeds, or excuse me, two velocities. You knew this one was going this way, this one was going this way. So again, if you remember and reviewed this one, all we had to do is go the distance, total distance, divided by the sum of the velocities. In this case is 17 plus 16 over 11 plus 10. Plus 16 divided by, 17 plus 16, enter, divided by 21, gets us 1.571 hours. Again, we're in hours. Well, that doesn't tell me what the question asks. The question asks, where did they collide? Hours is not a where. In some cases, I saw this come back on a few tests. That was the location. It's not the location, unfortunately. It is actually, you take 1.57 hours, 11 kilometers in 1 hour, times 1.571 hours. Again, 1.57 times 11. So runner A ran 17.285 kilometers. That's 285 kilometers more than the flagpole. So again, 2.285 was your distance, 0.285 away from the flagpole. It didn't say technically left or right, so I just gave you credit for having the 2.285. 0.285, that's all I was looking for. Okay? Again, very similar to the one we did in class. All right, so number 3. Bus slows down uniformly from 125 kilometers an hour to 55. This one 55. It's one version 55 kilometers an hour in 16 seconds. Yeah, sure. Each version gave you a little different numbers again. So kilometers an hour, and we're dealing with seconds. So to change kilometers, if you do dimensional analysis, 125 kilometers over 1 hour. 1 kilometer is equal to 1,000 meters. 1 hour is equal to 3,600 seconds. So you take 125 times 1,000 divided by 3,600. So my starting velocity is 34.72 meters per second. And we're going to do the same thing for the 55, times it by 1,000, divided by 3,600. My second velocity is 15.27 meters per second. This is actually one of the simplest problems that people had. They did not convert those to meters per second. Because we're in hours here and seconds here, you have to make it meters per second. It's one of the easy mistakes a lot of people did. So now the question wants to know, again, what is the distance the bus traveled? So you're looking for a delta x. So again, I can't jump up and down the screen about page 58 enough. My book would cooperate, that would be awesome. We have an initial velocity. We're looking for delta x. We have an initial velocity, we have a final velocity, and we know the time it took. So we don't need to look any further than that first equation. If you wanted to, you could have looked for a different equation and said, okay, any of these would have worked. But that's not the one we're going to go with. So we're just going to stick with a simple one, 1/2 VF plus VI delta T. So delta x equals, pardon me, back that back out. 1/2, my VF was 15.27, my VI 34.72 over times 16 seconds. 15.27 plus 34.72. Take that times 16. Whoops, come on. Times 16 times 0.5. Delta x should be 399.92. If you rounded it, which many of you did, delta x is equal to 400. If I was worried about significant digits, we would probably change that number because Technically, 2 significant digits is your least, so we'd have to worry about that. I'm not worried about significant digits. I did not count it on the test, so don't worry about that too much. Again, hardest part in this problem, convert it. A lot of people miss that. Okay. So let's jump to number 4. Number 4. So this is the one where car speeds up and slows down in one question. So the initial velocity. So car is traveling from rest. VF we do not know. It travels in this version, delta t was 8 seconds with an acceleration of 1.75 meters per second squared. Yes? And again, this has 2 accelerations. So VI we do not know over here. VF we do not know. Second half of this question applies the brakes for delta t of 2 seconds and has an acceleration in this version of negative 2.2 meters per second squared. Question asks how far it's traveled, so we need to know delta x. So delta x over the total. So again, if you look at page 58, I don't have a final velocity, I don't have a distance. So in this case, I do have an acceleration and a time. VF equals VI plus A delta t. It's probably the easiest equation. 0 plus 1.75 times 8 1.75 times 8 is 14 meters per second. VF here is 14 meters per second, which is cool because that's over here. That's a hideous 4, but you understand. But I also need the distance on this portion. Come on. So I'm going to need a delta x equation. Now I have a final velocity, so I can use the equation that we have used, 1/2 VI plus VF delta t. 0 plus 14 over 8 seconds. 14 times 8 times 0.5 gives me a delta x on this side of 56 meters. All right, we can do the exact same thing for this side. We know my initial velocity from here. So let's do it again. VF equals VI plus A delta t. VF is 14, or excuse me, VI is 14 plus an acceleration of negative 2.2 times delta t of 2 seconds. So in this case, 2.2 times 2, 14 minus 4.4. My VF was 9.6. That's my VF on this one. My delta x. Use the exact same equation. Delta x equals 1/2 VI plus VF delta t. So 1/2, my VI was 14 plus 9.6 over my time of 2 seconds. 14 plus 9.6 times 2 times 0.5. Delta x here is 23.6. I saw this on a few examples, a few people's, they picked either 1 or 2. 23.6 plus 56. 79.6. 79.6 meters. Okay. All right. 5 and 6 are the rocket problem. A lot of people got 300, and I think it was a matter of not understanding the problem when they said, okay, a model rocket shoots up and comes back down at some height. In this case, it was 300 meters. The engine shuts off. The initial speed, the VI on this version, gave us was 75 meters per second, and accelerates with 18.8 on this version. Wow, that's fast. It's looking for delta Y max. Well, we know there's 300 meters already, so it's got to go over 300. Well, I need to know the velocity at this point in time. So again, we look back at our equation. The best one I could see that we have, because we have acceleration, we don't have time. So if you look at the equations, you go, okay, I could find time, but it really doesn't ask me anything about it. If you look at question 6, it asks questions about time. So we're going to do the VF squared on this one equals VI squared plus 2A delta X. So let's answer this final velocity here, because I need that final velocity for the second half. Delta X, so VI is 75 squared plus 2 times the acceleration of 18.8. That's fast. That's a lot. That's really fast. Times 300. 75 squared is 5,625 plus 300 times 18.8 times 2. Wow, that's a big number. 280 plus the 5. So we're going to add them together. 5,625. It's huge. VF squared is equal to 6,905. And then we're going to square root that answer. Now let's try that again without the mistake. Square root of 16905. My VF is 130 meters per second. Now you say, why do I need that? Well, I need to know how fast I was going to get here. What is my final velocity at the top? That's the problem. Some people didn't understand the final velocity at the top is 0. So in this case, I'm going to use this exact same equation because now I know, again, VF squared equals VI squared plus 2A delta X. But now I'm looking for the distance. So this is 0 squared equals 130 squared plus 2. And what was my acceleration on this part? Why does it come to a 0? Why does it stop? Acceleration equals negative 9.81. Negative 9.81 delta X. Through the math, we move that over. So we have 16905 equals negative 9.81 times 2, 19.62 delta X. 16905 divided by 19.62. 861.6 meters. Now, here's where a lot of people made a mistake. They said, hey, I got 861. Plus that 300 initially. Your distance was 1,161.6 meters. That answer is number 5. Now I'm going to use the same piece of paper. I'm going to flip back and forth here because number 6 wanted to know the time it took to get there. So in this case, we have a lot of information we've already used. I'm going to use the simplest equation, VF equals VI plus A delta T. I'm going to solve for delta T. And I'm going to do it twice. because I've got two sets, one where it's speeding up and one where it's slowing down. So initially, my final velocity on the first one, 130 meters per second. My VI was 75. My acceleration was 18.8 delta t. This one, my final velocity is 0. My initial velocity was 130 plus negative 9.81. Come on. So, finish looking at the math. $130, subtract over the 75. We have 55 equals 18.8 delta t. Divided by 18.8, 2.93 seconds for this delta t. This one, you subtract over 130, so you have negative 130 equals negative 9.81 delta t. Oh, I missed the delta t here. 130 divided by 9.81. We have a 13.3 seconds delta t. And again, you have 2 times. Add them together. This comes out to be 16.2 seconds to get to the top. That was a very fast review. So let me know if you have any questions. Again, this is a review for the quiz. Take a look at yours. We're going to do a little bit more as we go forward.